Before we look at examples, I just want to discuss the exponent rules a little bit more in detail. So first, let's look at the product rule. The word product implies the answer to multiplication. So here we're multiplying 4 cubed by 4 squared. In expanded form, 4 cubed means you're multiplying 4 by itself 3 times. And 4 squared in expanded form is just 4 times 4. When you multiply all these 4's together, you end up with a total of 5 4's being multiplied together, which can be written as 4 to the exponent 5. Now this exponent of 5 can be obtained using the exponents of 3 and 2 simply by adding them. So the product rule states that when you're multiplying powers with the same base, you keep the same base, you keep that base, in this case 4, and you add the exponents. Okay. The next one is the quotient rule. Quotient is the answer to division, so here we're taking 4 to the exponent of 5 and dividing by 4 cubed. In expanded form, 4 to the exponent of 5 represents 4 being multiplied by itself 5 times. And 4 in expanded form is 4 times 4. And we can divide out 1 4 from the numerator with 1 4 from the denominator, because 4 divided by 4 is essentially 1. And that leaves us with 4 times 4, or 4 squared. This exponent of 2 can be obtained simply by subtracting the exponents 5 and 3. Okay, so the quotient rule states that if you're dividing powers with the same base, you keep the base the same and you subtract the exponents. Next, we can look at power of a power, power of a product, and power of a quotient. Here we have 4 cubed, that's a power and it's being squared, so we have a power within a power. And 4 cubed squared in expanded form means 4 cubed times 4 cubed, which means that we're actually multiplying a total of 6 4's together, since 4 cubed in expanded form is 4 times 4 times 4. And that can be written as 4 to the exponent 6. This exponent of 6 can be obtained by multiplying the exponents of 3 and 2. In the next example here, we have 4 being multiplied by x cubed. So this represents a product. And that product is the base of my power. So this is a power of a product. In expanded form, 4x cubed means I'm multiplying 4x cubed by itself. So 4 times 4 is 4 squared, and x cubed times x cubed is x to the exponent 6, because there's a total of 6 x's being multiplied together. To get these exponents of 2 and 6, I can simply multiply the exponents on my bases. So the exponent of 4 that's implied here is 1 if you don't see it. That exponent of 1 gets multiplied by 2 to give us an exponent of 2 in our answer. And then the exponent of 3, that x is raised 2, is multiplied by the 2 to give us an exponent of 6. And in the final example here, we have 4 cubed divided by 5 cubed. Since we're dividing, this represents a quotient. So the base is a quotient and it's being raised to an exponent. So this is a power of a quotient. Okay. And in expanded form, it means that you're taking 4 cubed divided by 5 cubed and multiplying it by itself. When we multiply fractions, we multiply the numerators and we multiply the denominators. So if I multiply 4 cubed by 4 cubed, I get 4 to the exponent 6. Since from my product rule up top, I can simply add the exponents. Okay? And then 5 cubed times 5 cubed would give me 5 to the exponent 6. I can get these exponents of 6 simply by multiplying the exponents that appear in the numerator and denominator by the exponent that's on the outside. So in all of these cases here, where I have a power of a power, power of a product, power of a quotient, I'm multiplying the inside exponents by the exponent on the outside. Okay, so these are the exponent rules. So let's look at examples here. So this is example 1. It says simplify. So we want to leave our answers as powers. We don't need to evaluate them. We don't need to figure out what the actual numerical value would be. We're going to leave them as powers. So we're going to express our answers as some base raised to an exponent. Part A, we have 5 cubed being multiplied by 5 to the 7. So since we're multiplying powers with the same base, we're going to apply the product rule. We're going to keep the base the same, which is 5, and we're going to add the exponent. So 3 plus 7 added together, it gives us 10. In the next example, we have 6 to the exponent 8 divided by 6 to the exponent 5. We're going to apply the quotient rule since we're dividing here, which means we leave the base as 6 and we subtract the exponents. 8 take away 5 is 3. In the next example here, we have a power within a power. So this is a power of a power. The power that's being raised to the exponent 5 is negative. 6 to the exponent 4 is the power, and that entire power here is negative. Okay. The rule when you have a power of powers to multiply the inside exponent by the outside exponent. So 4 times 5 is 20. So I will write this as negative 6 to the exponent 20. Like this. The entire power will be negative since I'm multiplying 6 to the exponent 4 an odd number of times. And if there's an odd number of negative signs being multiplied together, I will get a negative answer. In part D, I have a power of a quotient because I'm dividing 3 by 4. The implied exponents on the 3 and 4 are 1. Okay, and I would have to multiply these exponents of 1 by 2. So the numerator in my answer will be 3 squared, since 1 times 2 is 2, and the denominator of my answer would be 4 squared. Since I'm multiplying the exponent here that 4 is raised to by the 2. Okay. Part E, I first have to simplify the numerator by applying my product rule, which means that I keep the base the same. So I keep it as 3, and I add the exponents of 2 and 4 to give me 6. Now I'm going to apply my quotient rule since now I'm dividing. I keep the base the same, so again it's going to stay as 3, and I'm going to subtract my exponents. So 6 take away 3 gives me 3. Okay, the next question here, I have a power of a power in the numerator and denominator, which means I have to multiply the exponents. So 3 times 5 gives me an exponent of 15. So that would be the exponent that I would raise the 2 to in the numerator. In the denominator, I would raise the 2 to an exponent of 8, since 4 times 2 is 8. Now I'm going to apply my quotient rule since I'm dividing. That means I keep the base as 2 and subtract my exponent. So 15 take away 8 gives me 7. And here's the last example here. I have 5 to the exponent 6 being multiplied by 5 to the exponent 7 in the numerator. If I apply the product rule, that would simplify to 5 to the exponent 13. In the denominator, I have a power of a power, which means I have to multiply the exponents. Give me 5 to the exponent of 9. Okay. Now I have the quotient rule that I'm going to apply here. So I keep the base as 5 and I subtract my exponents. Give me a final answer of 5 to the exponent 4. Okay, let's look at another example here. Here are some of my bases that I see of my powers. There are variables, but you would still apply the same exponent rules regardless of whether the base is a number or a variable. Okay, so brackets in the first example imply multiplication. You would multiply the numbers like you normally would. So 5 times 2 is 10. And then you would multiply the powers with the same base by adding their exponents. So x squared and x are powers with the same base of x. I'm going to add their exponents. Remember, if you don't see an exponent 1 is implied. So I have to add the exponent of 2 to the 1 together to give me an exponent of 3. So x will be raised to the exponent of 3 in my answer. Then I look at the powers of y and add their exponents. So 3 plus 5 gives me 8. So the final answer for this question would be 10x cubed y to the 8. In part B, I'm dividing. So again, divide the numbers like you normally would. So 40 divided by 8 gives you 5. And then you're going to divide powers with the same base. You're going to divide x to the exponent 7 by x to the exponent 2. So that means you would have to apply the quotient rule and subtract the exponents. So when I take 2 away from 7, I get 5. So I would end up with x to the exponent 5 in my answer. Looking at the powers of y, subtracting their exponents, I end up with y cubed. So the final answer is 5x to the 5 y cubed. In part C here, okay, I have a power of a product. Okay, because I have a product of 3x squared and y to the 4th, and it's all being raised to an exponent of 3. So I have to multiply the exponents of all the different bases inside my brackets by the 3 exponent on the outside. Remember, the 3 inside the brackets has an implied exponent of 1. Multiplying the 1 by 3 gives me an exponent of 3. So 3 would be raised to an exponent of 3 in my answer. When I look at my power of x and I take an exponent of 2 multiplied by 3, I get x to the exponent 6. When I look at my power of y, I take the exponent of 4 multiplied by 3 to give me y to the exponent 12. In the denominator, I would still have 9x to the exponent 5, y to the exponent 10. Now, when you end up with power with a numerical base like this, you can evaluate it. So 3 cubed means 3 times 3 times 3, or 27. And now multiplying the numbers, dividing the numbers 27 and 9 gives me an answer of 3. Dividing the powers of x by subtracting the exponents, I would end up with x to the exponent of 1, which I won't write in because it's implied. Okay, since 6 take away 5 gives me 1. And the exponent on the y would just be 2, since I'm subtracting 10 from 12. So the final answer would simply be 3xy squared.